Hello. In this video, we're going to look at the surface area and volume of some common three-dimensional figures. So starting out with a really basic rectangular prism, the volume we'll start with. The volume is actually really straightforward for a shape like this, but I want to call it something that will apply to a variety of different shapes. So essentially, no matter what, if I consider one of these rectangles to be my base, so I'm going to consider this 5x6 rectangle to be the base, the volume of any of these shapes will be the area of the base times the height. Essentially, if I imagine that area of the base was sort of stacked all on top of each other a bunch of times, that'd be the height. That can sort of be considered the volume. So then if I get more complicated shapes, like a triangle or a hexagon or a circle or whatever, it's always just going to be the area of the base times the height. I have a rectangular base here, so that is just the length times the width times the height, which in this case is just 5 times 6 times 10, which is going to be 300 cubic centimeters. So fairly straightforward on the volume. This one's also pretty straightforward on the surface area because the surface area, the total area, is essentially just the sum of all of the individual two-dimensional faces of this shape. And in this case, I have 6 rectangular faces. So the area is going to be 2 times the rectangular face that I called the base. So 5 times 6, that's the base and the top, the way this is currently sitting, plus 2 times the 6 by 10 base, so the one that would be found on the right and on the left, the way this diagram is currently sitting, plus 2 times the 5 by 10 base, which would be the front and the back, the way this is currently oriented towards me. So 2 times 5 times 6 is 60, 2 times 6 times 10 is 120, and 2 times 5 times 10 is 100. So altogether, we have an area of 280. Now, this is a two-dimensional area, so centimeters squared. And that is the surface area of the shape. So hopefully nothing too terribly complicated in there. Those same principles are going to help us for more complicated shapes. So for example, in this case, I have a triangular prism. The triangle in this case is at the front, but I am actually going to consider that the base. So remember, the volume is the area of the base times the height. Now, in this case, the height is actually going to be this measurement, 35 inches, because if I'm considering the 9 by 40 triangle to be my base, if I flipped it up so that was on the bottom, then this 35 inches would be the height. So the area of the base in this case, well, it's a triangle, so 1/2 times the base of the triangle times the height of the triangle, which is 9 times 40, and then times the 35, which is the height. So if I get 1/2 times 9 times 40 times 35, altogether I have 6,300, and this is, cubic inches. So that is the volume of this rectangular prism, or triangular prism, sorry. If I want the surface area, so I'm going to have to think about sort of the shapes that I have. Now, I do have 2 triangles, so that's a pretty straightforward one. The triangles are going to be 2 times. The base triangle is 1/2 times 9 times 40. So 1/2 times 9 times 40 is 360, but I multiply it by 2. All right, so then the other faces. So at the top here, this rectangle is 35 times this length, which I don't currently know. That's actually the hypotenuse of the right triangle, so I'm going to call that x. So x squared equals 9 squared plus 40 squared. So when I solve that, I get that x is going to have to be 41, which means that this top rectangle is 35 inches times 41 inches. Now I also have a rectangle on the bottom here. So that bottom rectangle is going to be the 35 inches along the back times the 40 inches. And finally, I have a rectangle here, which is going to be 9 by 35. If I add all of these together, I guess I didn't really write this very well, but that's okay. If I write all these together, so 360 plus 35 times 41 plus 35 times 40 plus 9 times 35, we end up with 3,510, and this is an area measurement. So those are square inches. All right, so our next shape we have to deal with. All right, here we go. Our next shape is a cylinder. But in some ways, we can think of this as exactly the same as the prisms we were dealing with, where our base is a circle. So to find the volume, the area of the base is actually the area of the circle, which is pi times the radius squared, in this case 5 being the radius, and then times the height of the cylinder, which is 12. So if I do this as an exact value, the 5 squared times 12 is 300, which would mean the exact value of this volume would be 300 pi centimeters cubed. If we do want it just as an approximation, then I can actually multiply 300 by pi, and we get approximately 942 centimeters cubed. So depending on what the question is asking, you may need to give it as exact, or you may need to round it. Surface area is a little trickier here. The area in this case is going to be 2 times pi times 5 squared, because I have a circle on the bottom and a circle on the top. And if I consider what's called the lateral area, so the lateral area is this part wrapped around. If I basically unwrap that cylinder, that is a rectangle. The height of the rectangle is the 12 centimeters, and the width of the rectangle is going to be the circumference of the circle. So the circumference of that circle is 2 pi r, which is 2 times pi times 5, or 10 pi. So the area is the two circles plus 2 times pi times 5 times 12 for that lateral area, that's the rectangle. Now, depending on the actual context, you might have a cylinder that doesn't have a top and a bottom, in which case you're only using the lateral area. Or maybe it only has a bottom and no top, in which case you're using just one circle. So you kind of have to be smart about it and adjust as necessary. If I am using an exact value, then I'm going to end up with, this is going to be 50 pi. And the lateral area is going to be 120 pi. So altogether, the total area is 170 pi. And this is centimeters squared. Or if I want it as an approximation, 170 times pi is about 534 centimeters squared. All right. Gets a little bit trickier if I have things like pyramids, because now I essentially have like a part of the prism if this was a full rectangular prism. I have a square-based pyramid. Oops. This is obviously pulled from French. The pi is not for pi, it is for feet. So these are units in feet. All right, so we have a pyramid. Now the volume of this pyramid is going to be 1/3 of the area of the base times the height. Where that 1/3 comes from, you will actually discover when you learn calculus why it's 1/3. But it's correlated to the fact that the area of a triangle is 1/2 the area of a comparable rectangle. The volume of a pyramid is 1/3 the volume of a comparable prism, because now we're in 3 dimensions instead of 2. So the area of the base here, well, that's a square. So this is 1/3 times 12 squared times the height, which is 8. So 12 squared is 144 times 8, and then dividing that by 3, we get 384. And in this case, this is cubic feet. For the surface area, now this is also tricky for a couple of reasons. We have our base, that part's easy. So this area of the base is just 12 squared. But we also have these 4 triangular faces. So 4 triangles, each of which is going to be 1/2 their base. Well, the base of each of these triangles is 12. But now it's the height of the triangle, which is not the same as the height of the pyramid. So we actually call this the slant height of the pyramid, which I'm going to label with an S. And the slant height of the pyramid is currently unknown, but I do have a right triangle in the middle of this pyramid that I can use to discover it. So essentially what I have is the base of this right triangle is 6, because it's half of the base of the pyramid, and it has a height of 8. So that means that S squared equals 6 squared plus 8 squared, which when we solve that gives me S equals 10. So that is the height of the triangle that I use to find the area. So the base here is the 144, Each of these triangles is going to be 1/2 times 12 times 10, or in other words, 60, but I have 4 of them. So a total of 240. So when I add this together, I get 384 square feet. Kind of an interesting coincidence in this case that we have the same numerical value for our volume and our area, but they're not the same because they have different units. One of them is 3-dimensional and one of them is 2-dimensional. Similarly, for a cone, the volume of the cone is going to be 1/3 the area of the base, which is pi times the radius squared, and then multiplied by the height of the cone. So the volume here as an exact value is going to be 25 times 8. So 200 pi over 3, or 200 over 3 times pi. And this is centimeters cubed. And if I want this as an approximate value, this is about 209 centimeters cubed. Surface area is a little bit trickier because for surface area, I need to imagine what that lateral area is going to look like. So the area of the base, that one's easy, pi r squared. But this lateral thing, if I unroll it, is kind of a part of a circle. And the area of that part of the circle is a little bit more complicated. So what we need to consider here is the radius of this circle, which is not the same as the radius of the base. So I'm going to call that A. On the cone, that correlates to this value right here, A, the slant height. Its actual technical name is the apotheme. Apotheme, spelled like this, is basically the slant height. So I need that slant height because what it turns out is that this area is going to be pi times the radius of the base, so that's the 5 here, but times the apotheme, or the slant height. So in other words, in this instance, pi times 5 squared, that's going to give me the area of the circular base. And pi times 5 times this slant height, which I need to figure out. A squared equals 5 squared plus 8 squared from the Pythagorean theorem. So 5 squared plus 8 squared is not actually a perfect square, it's 89. So A is the square root of 89, which means that here I multiply by the square root of 89. Now, because I have that value, I'm not going to bother with an exact value here. I'm just going to give an approximate. So I have 25 pi plus 5 times the square root of 89 times pi, which gives me an approximate area of 227 centimeters squared. All right, so that is a cone. This formula here, again, the pi r A, this is the lateral area where A represents the slant height. And then our final shape is a sphere. And again, in calculus, you'll learn where this formula comes from. But the volume of a sphere is 4/3 pi times the radius cubed. So again, I forgot to translate this from French, so that is in inches. The volume is going to be 4/3 times pi times that 6 cubed. Oops, I wrote 3. Don't know why I wrote 3 when I said 6. It is 6. So 4/3 times 6 cubed is going to give me 288. So the exact value would be 288 pi cubic inches. If I actually multiply it out by pi, I get approximately 905 cubic inches. So depending on what the question asks, it'd be one of those two things. And again, the surface area, this formula will make more sense once you have learned calculus, but for the moment it is 4 times pi times r squared. So in this case, 4 times pi times 6 squared. 4 times 36 is 144, so we have 144 pi square inches, or if we want to give an approximate value, that is about 452 square inches. So these two formulas, again, they will make a little more sense once you've learned some calculus, but for the time being, that is the area and volume formula for a sphere.